Thank
Thank
you.
you so much for that introduction. As was mentioned, my name is Lisa Perez, and I'm the director for the Advanced Computing Enablement Group here at High Performance Research Computing. So today, what I wanted to talk about as part of this series that's being put on by the Center for Teaching Excellence is the resources that we have available if you are interested and have a desire and need to incorporate AI in the classroom, which as we go forward, we're seeing more and more in all disciplines, that it really needs to be introduced early, and you need those resources available for the students to use. Okay. So what is Texas A&M's high performance research computing? Our primary mission is to provide computing resources. But more importantly, or what I consider to be more importantly, is to provide consulting, technical guidance, and training to support not only researchers, but the students and university courses to utilize those resources. And then we also collaborate on computational and data-enabled resources. So primary for high-performance research computing is providing the hardware. So without the hardware, you can't do the high-end computing. So we have 4 main clusters. We have a couple of other ones that have niche computing. But we have Grace is our flagship system. We have Faster, ASIS, and Launch. So what's important for these clusters, especially with an AI focus, are the special features that are available on Grace, Faster, ASIS, and Launch. So we have a lot of compute, a lot of core that are available, almost 45,000 core on Grace, 11,000 on Faster and ASIS, and 8,000 on Launch. But if you look at Grace, Faster, and these other systems, we have quite a few GPUs, and these are not your standard GPUs. These are server level GPUs. These are the types of GPUs that are used to train large language models. So on Grace, we have quite a few A100s, 200 of them. On the Faster system, we have 40 more A100s, a large number of T4s. And on our newest system here, we have the H100s. So if you really need that heavy duty computing, and then on Launch, we also have additional A30s that are available. And these are critical for running those AI workloads. So we have substantial support for AI ML. Okay, we try to make it as easy as possible for a user to hop on our system and start using the standard AI ML workflows. So we have modules, software that's already installed for the professor that's teaching the course, for the students to ingest, and for the researchers. We have shared data sets. If you're doing a lot of AI ML, chances are you're going to need a lot of data, and trying to provide those large data sets to the students can be quite cumbersome and complicated. So we already have a lot of data sets that are available, and all of your standard tool sets that are used in the AI ML field. So the other important thing that we provide to support the AI ML workloads in the university courses is ease of access. Standard interface that the students are used to using, Jupyter Notebooks, Jupyter Lab, heavily used in AI ML. We support that right through the web browser. Okay, so you do not need to learn any special techniques to log into the supercomputers to run these workloads. You can fire up a Jupyter Notebook or a Jupyter Lab directly in your web browser using the portal. If you're running AI ML, chances are you've also looked into using containers. This is very popular and often is confusing for people when they first start trying to run these workloads, especially in an HPC environment. And we support these native container workflows on our HPC systems in a very easy to use fashion. You can fire them up directly through your Jupyter Notebook or Jupyter Lab session. We have a lot of software already installed. That's other major difficulty incorporating this into the coursework is getting all of the students to have the software that they need to run some of these complicated workflows, even some of the simple workflows. Installing Python is non-trivial in a lot of ways, and getting all of the different subroutines that you need and modules that you need to run all of the AI ML workflows is complicated. We have the vast majority of these already installed. So for example, on ASUS, we already have 1,500 plus software modules available. And if you're looking for a particular one, you can search and find it. And if you don't find it, you can reach out and we'll install it. Very important is the training that we offer. Okay, so we have every semester, we have primer, short courses, tech labs, and workshops that cover a wide variety of topics. You can peruse some of our short course offerings that we've had in the past on our YouTube channel. So we have 1,540 subscribers now for our YouTube channel, and lots of good training sessions that are available with a focus on AI/ML and some of the other techniques that you'll need to really incorporate AI/ML in your coursework. So I want to focus on one of the training sessions that we offer that is very beneficial for people who are first starting with AI/ML in an HPC environment, and specifically on our systems. So this is the AI Tech Lab, and the training sessions are available on our YouTube channel and all the documentation on our training short course. So there's 4 sections. The first one is just getting on with Jupyter Lab. As I mentioned, we make this very easy. And then it goes through data exploration. Data is always one of the biggest stumbling blocks, right? When you're getting started with AI/ML, making sure that you have your data, how to get it loaded, making sure that it's appropriate data, that it's balanced, it's fair. And then going into the details of, deep learning for AI/ML workloads, machine learning, and what the differences are for those. So it takes step by step, and this is designed to really get the student and researcher running immediately, okay? And introducing the topics as you're doing the hands-on sessions. So the first one is just getting Jupyter Lab, how to fire it up on the HPC system. Okay, and then the Jupyter Lab is used because it gives that flexibility where you can run a Jupyter notebook, you can fire up a terminal if you want to, you can manipulate your text files directly in the Jupyter Lab, and it just makes everything very simple and straightforward to get your students up and running quickly. For the lab 2, the data exploration, we use common libraries that are available, Matplotlib, Pandas, to manipulate that data, talk about how to display that data and do analysis on it. And then we move into the machine learning and all the different levels of machine learning, talking about the basic concepts that you need to learn to move into the AI/ML. So classification, clustering, with a focus on using scikit-learn. Talking about the fundamentals, very, very important for the different algorithms: supervised learning, unsupervised learning, reinforced learning, and delving into those topics. And this is a 2.5-hour course, so it's introductory, learning those techniques, learning the terminology, and providing the computational resources to apply that learning. Okay, and then the last one, moving into deep learning with TensorFlow and PyTorch, providing those resources for the researcher and student to understand the concepts and give them resources to learn more deeply about those concepts. Understanding the relationship between AI, ML, and deep learning. Artificial intelligence being the very global, encompassing everything, machine learning being a subset, and deep learning even a deeper subset of the artificial intelligence. Okay, I want to talk a little bit about some of the novel hardware that we have. So we provide those resources. We have the training sessions. We make it very easy for instructors to incorporate these resources into their classroom environment. We also have advanced resources, and you will see more and more of this as we move into the broader reach of AI/ML across the different disciplines. So 2 of our systems that we have are composable systems. So what I'm showing here is that we have traditional server configurations. Okay, so we have that the large supercomputing systems. They have the internal components, you have your CPUs, and you have your advanced resources like the accelerators that are on the motherboard. And that configuration is set. So for the life of your system, that configuration is set. The new systems involve composability, and ours involve composability at the hardware level. And what we have is a pool of servers. We have a pool of accelerators, GPUs and advanced accelerators like FPGAs. And then we have a pool of memory, okay? And we can recompose these using something called the liquid fabric into new servers. So we don't have to go and purchase new servers. We can reconfigure these resources in the pools to make the servers that we need. So if you're doing some very advanced work where you're trying to run with multiple GPUs, you can redesign your hardware with multiple GPUs on a single server. So 4 GPUs, 8 GPUs, 10 GPUs, okay, or whatever PCIe that you need. So this is ASUS and faster, and we try to make it transparent to the end user. You talk about the resources that you want, and it composes the resources for you. Okay, so you can really scale up. So if you're incorporating AI ML in capstone projects, okay, where they're doing more advanced computing, they can utilize these higher end composable resources to get multiple GPUs to run their AI ML workloads. Okay, so all things start at our webpage. For more information, because in the time that I had, I just wanted to give you a basic overview of what high performance research computing is and how it can be applied to incorporating AI into your courses. So if you want more information, definitely come to our webpage. We have quick links on the side. You do have to apply for an account. And then I also added a special link here. This is a page specifically set up for how to host courses on our resource. Okay, that lays out the basic steps that you need to go through to host a course on our resources. Very, very importantly, HPRC resources are free of charge to all faculty, research staff, students, and external collaborators. Okay, so there's no fee for using our resources. Application is required for access. Okay, and you can find out more information at our webpage. Okay, so I thank you everybody for coming on this very, very important day right after the solar eclipse. I ran back in for the presentation. And at this time, I will open it up for questions.